Okay, so for problem number 9, first thing we're going to identify are the vertical asymptotes. Remember, vertical asymptotes are caused by division by 0. So the thing we're dividing by for this problem is x squared minus 3x minus 4. And we're concerned about when that will equal 0, because 0 is the number we can never divide by. So I'm going to take that denominator, set it equal to 0, and solve. Because it's quadratic, I've got to factor it. So my product is negative 4x squared. My sum is negative 3x. I want to multiply to negative 4 but add to negative 3. I need negative 4 and positive 1x. So I can use down from and generic rectangle to factor this. So we factor out every row and column what they're divisible by. And we see that this factors into x minus 4 times x plus 1. So then we use zero product property to set each one of those equal to 0 to solve. So if x minus 4 equals 0, we get x equals 4. I need some more room, so I'm going to shrink this down a little. Okay, and then if I set the other one equal to 0, so if x plus 1 equals 0, I solve, I get x equals negative 1. So all of that work was to find my vertical asymptotes, because remember, to find those, we set them equal to 0, we set the denominator equal to 0 and solve, because it's caused by dividing by 0. There we go. So I'm going to fill in vertical asymptotes, x equals 4 and x equals negative 1. And I'm going to dash them in on my graph. So here's a vertical asymptote at negative 1. Here's one at positive 4. And now horizontal asymptote, I check the degree. So the degree of the numerator, since there's no exponent here, it's a 1. The degree of the denominator, it's a 2. So degree 1 compared to degree 2, it's bottom heavy. The bottom is larger than the top. And anytime it's bottom heavy, the value of that fraction is headed to 0. Because the bottom's going to keep growing larger and larger, making the overall value of the fraction smaller and smaller and smaller. So we head to 0. So here's my horizontal asymptote at y equals 0, otherwise known as the x-axis. My domain, I know for sure, that's always broken up by the vertical asymptotes, so I can't equal negative 1 or 4. So I can be everything less than negative 1, everything between negative 1 and 4, and everything bigger than 4. So there's going to be 3 sections of graph. This section here, this section in here, and then a section over here. My range, I'm not sure of, because I could cross that horizontal asymptote. So I want to graph it first before I fill in anything here. And then now we're going to do x-intercepts. So x-intercepts, places where the graph touches the x-axis, which is our horizontal asymptote. So right here we're going to find out, does it touch the horizontal asymptote? Well, if we are on the x-axis, y is 0. So we're going to replace y with 0 and attempt to solve. So we have 0 equals x minus 2 over x squared minus 3x minus 4. I'm going to make the left side a fraction so that I've got a fraction on the right, fraction on the left, and that's called a proportion. So I can cross multiply in order to solve. So if I cross multiply, 0 times that denominator is just going to be 0. 1 times the numerator is just going to give me the numerator. So I get 0 equals x minus 2. And so then if I add 2 to both sides, I see x equals 2. So my x-intercept is 2, 0. And so now I know I do cross that horizontal asymptote. And so my range is not going to be broken by the horizontal asymptote. Remember, horizontal asymptotes just talk about end behavior. So I know as I go to the extremes to negative infinity and to positive infinity, it's going to level out to 0. So, maybe here or below or here or below. I'm not sure which side it's on yet. But it's going to level out to that value. Okay, so x-intercept is 2, 0. For the y-intercept, we're going to plug in 0 for y and solve. So y equals 0 minus 2 over 0 squared minus 3 times 0 minus 4. We simplify 0 minus 2, give you negative 2 in the numerator, and then in the bottom 0 squared is 0, 3 times 0 is 0, so 0 minus 4 gives you negative 4. Negative divided by negative is a positive, and 2/4 reduces to 1/2. So our y-intercept is 0, 1/2. And then we need some more points to plot in order to be able to graph this. So I'm going to create an XY chart. And again, you can use a graphing tool like one of the graphing calculator apps or Desmos to help you get a good picture of what these look like and define points. So I'm going to do like -4, -3, -2. Can't do -1 because that's a vertical asymptote. I already did 0. I'm gonna jump to 3 next for one more point in that middle section. And we'll do like 4, 5, and 6. So if you plug -4 into the original function, you'll get -6 in the top. So -6 over 24, so that's -1/4. If you plug in -3, you get -5 in the numerator, and 25 plus 15 would be 40, minus 4, 36. -5, 36, so just above 1/4, but so still real close to that horizontal asymptote. If we plug in -2, we'll get -4 for the numerator. In the denominator, we get 12, so that's -1/3. So slowly but surely moving our way up. So I'm gonna have a piece here. And then if I plug in 3, I'd have 1 for the numerator. 9 minus 9 would be 0, -4. So I'll have -1/4. So I'm gonna guess this piece is gonna come along my vertical asymptote, go through those, and curve down. If I plug in 4, I'd have 2 for the numerator. 16 minus 12 would be 4 minus 4. Oops, I didn't mean 4, that's my vertical asymptote. Undefined, I'm getting divided by 0 because it's my vertical asymptote. I need to jump to 5, so I'll do 5, 6, and 7. So if I plug in 5, 5 minus 2 is 3. In the bottom, 25 minus 15 will be 10, minus 4 is 6, so 3 6 or 1/2. Plug in 6, I get 4 in the top. 36 minus 18, 18 minus 4, 14 or 2/7. So I'm just going to get closer and closer, so I'm going to guess this piece is here. And again, we can use a graphing tool to help us check that. And let's do that now. So I'm going to use Desmos. You could also use a graphing calculator or graphing calculator app on your phone. But we've got to type it in. Key is parentheses. So you have to put the entire numerator in its own set of parentheses. So that it knows all of that is in the top of the fraction. Divided by a new set of parentheses for the denominator. X squared minus 3x minus 4, close parentheses. So there's our function. And we can see I made a mistake when I was graphing. I graphed some of my negative points in the positives. So let's flip back over and I can fix that. These right here. I got negatives, but for some reason I plotted them in the positives. Silly me. So let me erase that quick and fix that. So I got negative 1/4. I just have to actually put it at negative 1/4. So then my piece is down here. So there's my rough sketch of the graph, and again, here's Desmos showing a more accurate picture of the graph, but what we can see is the range is everything. It goes all the way from negative infinity up to positive infinity. And it doesn't matter that there's 3 separate pieces. Range, we're describing bottom to top. Well, every value is used somewhere from the bottom to the top. So negative infinity to infinity is what we're going to write for our range. And there's our final problem.